3I Atlas has already passed through our solar system, and its closest approach to Earth is now behind us. That brief window was the most important phase of its entire visit, because it was the moment when astronomers had their clearest and most detailed view of this interstellar object. During that period, new observations began to refine what we thought we knew. Measurements improved, uncertainties narrowed, and some early assumptions had to be reconsidered. In particular, updated data led scientists to revise estimates of 3I Atlas actual size, and those revised numbers don't fully align with the picture that was forming in the months before its closest approach. This is a normal part of astronomy. Early estimates are based on limited information, and they change as better data becomes available. But in this case, the timing matters. Now that 3I Atlas is already moving away from the sun and fading from view, there is no second chance to confirm those details. What we thought we understood at first, and what the data suggests now, are not identical, and that difference is where the real significance of this closest approach begins to emerge. Astronomers around the world confirmed that interstellar comet 3I Atlas made its closest approach to Earth on the 19th of December 2025. According to NASA and multiple scientific reports, at approximately 1 a.m. EST, on that day, 3I Atlas passed by Earth at a distance of about 1.8 astronomical units, roughly 168 million miles, or 270 million kilometers from our planet. This event was significant not because the comet came extremely close in a physical sense, it remained far beyond the orbit of the moon, but because it represented the moment when telescopes and spacecraft could capture the most detailed data during the object's passage. Multiple observatories, including ground-based telescopes and space telescopes like Hubble and James Webb, focused on 3I Atlas before its brightness faded as it moved away. Before its closest approach, scientists had already been tracking the comet's motion since its discovery on the 1st of July 2025 by the NASA-funded Atlas survey in Chile. 3I Atlas was identified as an interstellar object due to its hyperbolic trajectory and unusually high-speed characteristics only consistent with something not bound to the sun's gravity. When first observed, 3I Atlas was traveling at about 137,000 miles per hour, 221,000 kilometers per hour, relative to the Sunday. As it approached the inner solar system, the sun's gravity accelerated it further, increasing its speed to approximately 153,000 miles per hour, 246,000 kilometers per hour, near perihelion, its closest point to the sun, on the 30th of October 2025. After its Earth close approach on the 19th of December 2025, the comet continued on its outward path, slowing slightly as it climbed back out of the sun's gravitational well. Its motion confirms it will eventually escape the solar system, continuing its journey back into interstellar space. As 3I Atlas moved through the solar system toward its closest approach to Earth on the 19th of December 2025, astronomers worked hard to refine its physical properties. One of the most challenging and debated measurements has been its actual size, because interstellar comets are surrounded by a bright cloud of gas and dust, the coma, which makes it difficult to see the solid nucleus directly. Early estimates, based on brightness and assumptions about how much sunlight the nucleus reflects, placed the diameter of 3I Atlas's core in a very broad range, anywhere from a few hundred meters up to several kilometers. Observations from NASA's Hubble Space Telescope and other instruments suggested a nucleus diameter between about 0.32 kilometers and 5.6 kilometers. That large span reflected uncertainty in the object's reflectivity and the contribution of the coma to its brightness. As more data became available, including images taken by the Mars Reconnaissance Orbiter's HiRISE camera and other space missions, scientists refined their models. Observations of how the comet's motion deviated slightly from a simple gravitational trajectory allowed researchers to estimate how much gas outgassing was pushing on it. Models that fit this non-gravitational acceleration suggest the nucleus is likely around 0.8 kilometers to 1.05 kilometers in diameter, substantially smaller than the high end of earlier estimates and more consistent with typical comet nuclei. This downward revision from a wide early range to a more concentrated estimate near about 1 kilometer across does not mean the original measurements were wrong, but rather that better data and modeling improved our understanding. As 3I Atlas faded after its closest approach, astronomers relied on every available observation to constrain the size more precisely, accepting some uncertainty because the coma still masks the nucleus itself. In summary, the scientific picture of 3I, Atlas's size, has evolved from a very broad initial estimate to a more refined range centered around a kilometer in diameter, illustrating how improved observations sharpen our view of rare interstellar visitors. As 3I Atlas moves farther away from the Sun, its brief visit to the inner solar system is already coming to an end. The closest approach to Earth marked the final moment when scientists could study this interstellar comet under favorable conditions. Everything learned after that point relies on data already collected. What stands out is not just what we discovered, but how limited the opportunity was. In a short span of time, astronomers refined its trajectory, observed its activity, and narrowed key physical estimates. And yet, much about 3I Atlas remains uncertain not because of mistakes, but because interstellar objects do not wait. Despite originating around another star, 3I Atlas behaved in many familiar ways. Its response to sunlight, the development of its coma, and its interaction with the solar environment all closely resembled comets from our own solar system. That familiarity suggests the processes that shape planetary systems may be common throughout the galaxy. Now, as 3I Atlas fades and continues this journey back into interstellar space, it leaves behind something more valuable than spectacle perspective. It reminds us that our solar system is not isolated and that material from distant stars passes through more often than we once believed. The next interstellar visitor will arrive without warning. The question is not whether it will come, but whether we will be ready to learn more when it does.